Oh, just a second. Are you able to see my screen?
Yeah, you're good.
You good? Okay. Okay, just put full presentation mode.
Okay, you're good.
Okay, just let me know, John, when you want to start. So.
No, you're ready to go.
Okay.
Yeah.
Okay, so good morning, everybody. I think a few months ago, we had this presentation was part one of this Lunch and Learn, where we were talking plant health diagnostics. So I just want to start with a little bit reminder of points that we have discussed last time whenever we talk about disease. So remember, we can have our plants can face abiotic and biotic plant problems. So what we call abiotic is everything that is caused by a non-organism, something that is not an organism, that is not a fungus, it's not a bacteria, it's not an insect. So everything that is not that. Whereas biotic, that's what we call plant disease, and then it's caused by something that is it's usually have a microorganism involved, and it's more constant, and there's an infection process going on. So just so we can talk a little bit, what are the abiotic plant problems? Some like environmental factors are the main cause by these abiotic problems, and they can be natural or man-made. And then, like I said, they are non-infections, non-living. So we can have, for example, unfavorable soil properties or structure, nutrient imbalances, moisture extremes, either drought or high humidity in the soil, temperature extremes, either cold or hot, light extremes, physical injuries, chemical toxicity, and in Florida, we also might have lightning strikes. And the biotic problems are the problems or disease that require second organism that will infect the plant and then disrupt any part of the growth or appearance of the plant. And then here we are talking about living organisms. Okay, so we think about it as plant pathogens like bacteria, fungi, oomycetes, nematodes, viruses, and viroids. So these are like just a picture of a plant cell and the size, like comparing the size of the different organisms. So it's interesting. And then I want to point out that sometimes when you get samples in the clinic, for example, if it's something that is caused by a virus, you will not be able to see under the scope. So usually if it's a nematode or fungus, it's pretty clear. But virus, it will never be able to see. So that's why it's so important to rely on symptoms to learn how to differentiate them. And another thing that I want to talk about here, and that's also important for whatever we've been seeing during this late in the year. We are in November, kind of approaching Florida winter, right? But we are having a lot of rain events. And that's very important for a disease that is caused by a pathogen, an organism to occur. So here we have, for a disease to occur, then we have a susceptible host, which is a plant that is very prone to disease development or to be infected or to show symptoms. We have the pathogen, which can be like the organisms that I mentioned, and we also have a favorable environment. So I want to talk about this favorable environment. And us, I know these pictures here might be a little confusing, but what I just wanted to show you that we as plant pathologists, we also do a lot of studies on environment. So what are the favorable conditions for a disease to occur? So here in the left, we're just showing that we tested different temperatures. Sorry, this is in Celsius, but it would be something between 30s and up 90s. and different wetness periods. So what I want to point out here, so the longer, what is wetness period? So how long does the leaf, especially the leaf of a plant, is wet, and especially due to high humidity or rain and the different temperatures. And here we see that most, like, what causes, like, the, in this case, the pathogen to grow and infect the plant is like longer disease wetness periods, and also temperatures that range, for example, from 20 to 25 Celsius. Let's say something between higher 60s and lower 70s. So it really depends on the pathogen. Every pathogen is different, but these are conditions that we are facing now in Florida, or we still have temperatures in the 70s, sometimes even the 80s, and humidity that is like lasting long hours. And sometimes that's how we see for disease too. So based on that, the plant pathologists, they put a number, for example, risk value. So they talk, oh, if we have rainfall, like how much rainfall did we have? So here in millimeters, but we can kind of change to inches too. So 1 inch, 2.5, 25 millimeters. So it here is even like less than 1 inch. Let's say 0.2 inches. And then also how long that the surface of the leaf is wet. So let's say the higher risk here for disease occurrence 10, it means you're going to have like a longer duration of wetness, and also a lot of rain. And so I work with strawberries mainly, and we have something very similar for strawberries as well. And we have a system that tells the growers, for example, when they're going to have higher incidence of a disease, a specific disease that affects the strawberries, but can affect other types of plants, which is the gray mold. So on the graph here on the bottom, we see that the higher incidence of the disease usually occur after we had events of rain or humidity, where they will call like high risks events. So that's just to show why sometimes we get so many problems now. So we've been having a lot of rain, so the disease are gonna appear. And with that, now we're gonna start like like we did a few months ago, and it's your turn to be the plant diagnostician. We're gonna be showing some pictures of plants with symptoms, and you have to figure out what's the problem with that plant. John, I don't know if you're gonna put the poll now. How are we gonna do that?
Yeah, let me pull that up here.
So you're gonna have 30, like last time, you're gonna have 30 seconds in each picture, and we also gonna have like the alternatives. So just if you get
Getting my handy dandy timer out here.
So just let me know when you're ready, John.
Can you see it? I just launched the poll.
I can see it. Okay. So first picture. Wait a second. Here you go. You can move the window side, right, John, and to see the picture. If you want to take notes too.
Move the window?
No, not you.
Okay.
Yeah.
Okay, 30 seconds.
Next.
Yep, good.
Next picture, number 3.
Thirty seconds.
Next one, number 4.
If you lose your poll, I guess just try and record it yourself on a piece of paper. I think it's going to be more of Zoom, not us. Okay, 30 seconds.
Okay. Next one, number 5. Okay,
30 seconds.
Picture 6. Okay, 30 seconds is up. Number 7. Number 8.
Okay.
Number 9. And the last one for this round, number 10.
Okay.
Okay. So, John, are you going to?
Yeah. I guess everybody go ahead and submit. I'll give you guys another 30 seconds or so to submit. Okay, I've got 10 of 27. 11 of 27. All right, I'm going to go ahead and end the poll. All right, well, I guess we'll just go through these.
Okay. So let's check our answers. So number 1 was black spot caused by this fungus named Diplocarpon. So John, what?
We got a pretty even match of A, B, and D.
A, B, and D. Okay, yes, actually, because they are leaf spots. So all of them are they're caused by organisms that cause leaf spot, and that's the symptom that you're observing. And then I know it might be tricky, and then sometimes it's only looking at by a picture. Sometimes it's hard. So sometimes that whenever I know you get a lot of like pictures and calls, they're gonna describe, and it's important that we have the history as well, and then if we can see under the scope, because in this case we might be able to see the signs of the fungus. In the case if it was bacteria, sometimes we do just a bacteria run and then you see a wooze, and that would probably not be the case for this one because that was a fungus, not a bacteria. But that one was hard, but good job.
Yeah, I mean, I guess just to kind of cover from what I've seen, the Cercospora, I think, tends to be more circular. I mean, nobody picked fire blight at all, so that was very good. And then I guess bacterial leaf spot, Pseudomonas, it tends to be kind of irregular shaped and more brown than black. So, and the margins tend to be less defined than what you see here.
Okay. Number 2. So powdery mildew, how did they do on that one?
Between powdery mildew and white flies, but more, a little bit more, 55% for powdery mildew.
Powdery mildew. Yeah, good job. So these are the things that are easy to spot, and just by looking with your hands as well, you can see the powdery structure. And then, of course, by seeing like this, it might look like white flies, but if you have those in hands, would be very easy to spot too. The other ones like smog pollution or ozone pollution, sometimes we see symptoms like that, but they would be probably a little bit of a different color, and then also the structures. You wouldn't be able to see the signs of the fungus that is the powdery mildew. And another thing that also helps with this diagnosis is like roses are susceptible to powdery mildew. So that's it. Anything you want to add, John?
No, not for this one.
Okay. Number 3, that was, I know it was a little tricky because again we had 2 rows symptoms, and then in this case was the one caused by the bacteria Pseudomonas, and that's what John was explaining. And then also looking on the, here we have a picture of like the downside of the lead too. So how did they do on that one, John?
We tricked them.
Yeah.
Because one of them had Rose Rosette, like that one was in the title. So, yeah, we got 45% for Rose Rosette. Okay. And then bacterial leaf spot was the next one, though. So.
Okay. So they did good. And again, if you have these samples in hand, you would be able to do a quick, like, you cut pieces and put it in water, and then you see the bacteria oozing out of that. Whereas for virus, that wouldn't be possible, and then you would have like to rely on the symptoms that are different.
Yeah. Okay. And just I guess just the big one, these diseases.
It's the halo. Yeah.
Oh.
Go ahead.
The diseases, yeah, there's the halo too. Mm-hmm. But the Rose Rosette disease is a virus, and it looks a lot different than what these foliar and fungal and bacterial diseases, the branches and the leaves will be very malformed, kind of. So it won't look anything like this.
Okay, number 4. That was one of kind of easy. Rust. So how did they do
Most
on
of them
that
got
one?
this one.
Yeah.
Some of them, a few thought that it was scales, but most of them got this.
Yeah, it might be, but I think the color would be a little different. And again, a close look into the microscope would help. Powdery mildew, again, also the powdery, it has more of a white structure. And as a rust is usually it's very orangey or yellow. And then when you touch it, you have the signs on your hands too. And again, we're talking about this is plumeria plant, and it would be very easy to spot around the area as well, and it's very susceptible to rust. Sometimes you see on the upper leaves too, because on the down the bottom side of the leaves you see the structures of the fungus, and sometimes on the top leaves that we are not showing here, but if you see out there you might see some kind of the discoloration of the leaves too. So it's always important to look on both sides. Next one, number 5. So how did they do that on that?
They did pretty good. 64% got
That
this one. And then the next one was low moisture or water deficiency.
Yes. So in that case, and here that's why we have this picture on the side to point out. If you look really close, you can kind of see some of the structures of the fungus here. So gray leaf spot in San Augustine grass is caused by this fungus, the puricularia, and you can see the structures of the fungus on the lesions. So you see all this the kind of the dark halo around, and then the white spot. If we had something that was more low soil moisture, we would see more of the plants wilting. And the leaf spots here, it's actually what calls our attention to that. But good job. Number 6. I know that was one that was tricky, right? So how did they do on that one?
Yeah, more of them got this one. So
Yes.
probably 60% here. So
Oh,
that's
good.
pretty good. I mean, that they were able to, it's localized whereas if it had been low moisture or water deficiency, you would have saw more uniform problems. Okay. And then
All right.
yeah, the gray leaf spot, yeah, like it was a little bit more uniform throughout the whole yard. So that's the big thing here, is just that it's so local, like that it's like something was applied there, and you got to keep that in mind as well for pesticides application by accident, that plants that might be burnt from excessive fertilizer if it got spilled right there, things like that. But yeah, most people got this one.
Okay. Next one, number 7, which is broom. So
We
how
got
did they do?
55% for witch's broom,
That's
and then
good.
45% for nitrogen deficiency, which I could see it's a little yellow. It looks a little
The
chlorotic.
leaves. Yeah. But in here, that's why we have the picture on the left, because we wanted to point out the structures of something growing here. So this is an indication that it's also organism that is causing it, and in this case, it's a fungus. And the fact that it calls like witch's broom, it's usually it calls these galls here, and then that's what makes the leaves kind of lose their color, because it jeopardizes the nitrogen uptake or other nutrients uptake. So that's why you see. So it's just a reflection symptom of the real disease. And sometimes that's what we see in plant pathology as well. And this might be true for some of the pathogens that cause like the plants to wilt. And the symptom that is reflected on the upper part of the plant is a nutrient deficiency. But yeah, you did good. Anything else, John? Can we go to the next?
Yeah, let's go to the next one.
Number 8. How did they do on that one?
Split between Pythium and nematode damage.
Nematode. And that's actually tricky. And then we really need a kind of corrected diagnosis for that. So I just want to congratulate you because you did well on that. So sometimes we really need to see under like with the proper tools. But the interesting thing about the pythium, which is a oomycete, so it kind of infects the roots and cause it to rot, but it starts moving towards the stem of the plant as well, and then also reduces the like just the mass, right? The number of roots and new roots, because here you kind of can see the new roots coming. But sometimes compacted soil would cause something like that to produce like less roots. But again, the symptom here, whenever it's moving to the stem of the plants, that's a good indicator that it's a pathogen. Anything else, John?
No, not for this one.
Okay. Number 9. That
Number
was
9.
track nose.
Most of them got this one.
Yes.
A couple said stem end decay, but
The stem end decay is very. You're right. Sometimes the symptoms are very similar, but like the name says, stem end. It usually starts on the stem of the fruit. That's the type of symptoms. And sometimes, if you leave this mango out, or even if you put it, if you want to just do an experiment at home and you don't want to eat this mango anymore, just put inside a plastic bag with a little humid paper towel, and you might start seeing some of the signs like orange color signs on the spots, and that was caused by the fungus polytoxicum. But this mango uh, you can still pretty much eat them. So okay, number 10.
number 10, more people went with low soil moisture, water deficiency, but we got about a third of them went for the petal blight.
Mm-hmm. And I guess that's because it's, again, like you mentioned, and it's just a reflex symptom. So you might think that is something in your soil that is causing it to wilt, but in that case, it was not. It was a pathogen. So you want to add something to that picture, John?
Yeah, I would say also just pay attention to the foliage because I mean, if you look at the foliage, they're not having any symptoms. Um, it's all concentrated on the blooms
Yes.
here. So
Mhm.
so I
Okay.
think that's it. And then let's go ahead and do our next 10.
Next 10. Do we have time? Okay.
Yeah, I think we got enough time. If anybody, I mean, we should be going to 45. I don't really have a whole lot to say for the meeting today, so we can just go ahead and go forward.
Okay. So let's start again. Be ready.
All right, let me go ahead, pull up the next poll. Oh, hold
This
on.
is the first one. Yeah.
Yeah, I got to pull up the. Okay, we're good now.
Okay.
All right, 30 seconds. All right. Okay. Good. Okay. I guess everybody go ahead and submit your answers. All right, we got more this time. We got 16 to 28. So I'm going to go ahead and end the poll. Thanks, Joe. All right. I guess we'll go ahead and go into our next one.
Just starting checking the answers.
Oh, wow. Everybody got this one. Imagine that.
Even though it didn't have the picture before, right? From the bug.
The culprit. Yeah.
Mm-hmm.
Yeah, good job. Everybody could tell it was being chewed on and it wasn't curling up on the ends or anything like that. It was actually being chewed on, so that means it could only be a couple types of insects, either caterpillars or beetles. In this case, it's a beetle. So, the next slide.
Oh yeah, sorry.
We've got a comparison between the Sri Lanka weevil, which is on the left-hand side, compared to the looper beetle. The big thing that works for me to tell the difference is this shoulder. You can kind of see that, like the looper on the right-hand side, he doesn't have the shoulders, but the Sri Lanka weevil does. So they're not that big. Maybe they're only like half an inch or so, but that's what's worked for me. They both cause pretty similar damage, but it seems like that we get a lot more of the Sri Lanka weevil these days since they've been introduced.
Hey, next one, number 12. That was a tricky
we got a
one
lot
too.
we got a lot of cypress canker. 63% for cypress canker and 25% for armillaria, and a few did the herbicide damage. So
I have that bean too. But oops. Yep.
So let's see here. Well, the big thing here is that I think that what we're looking at is that the whole plant is dying, and the canker, when that occurs, you typically see it more in sections. It doesn't tend to uniformly stress out the plant. Armillaria, the thing that is going on with it is it's actually the vascular tissue is being gummed up. The plant is not able to get water from its roots to the rest of the plant. And so it looks like it has heat stress and it's just dying from a lack of water, because that's basically what physiologically is happening to it. So, whereas, and it starts towards the tips, it's the same thing that you would expect to have happen from heat stress, prolonged drought, that type of thing. So, and that's what you see in this case. You got anything, Juliana? Okay.
Oh, no, I think you covered most of it. Mm-hmm. Number 13.
So for 13, yep, most people got this one. Mm-hmm. Almost everybody got this one.
Yeah, that was a few years ago. It was on a hunt that had recently introduced, and it was causing a lot of problems. And then we were on a witch hunt against this disease as well. But now it's pretty much everywhere in here. And again, you have to notice the symptoms on the roots, and also this reflection symptoms here again. It might also could have been something like herbicide damage, but I think we would be looking at something more evenly distributed, or even the excess of fertilization. We would have more of the symptoms would be more uniform. But this is a pretty typical case of boxwood dieback.
Yeah, and most people got it that if you knew you were looking at boxwood, then this is something we don't plant here specifically because it's such a problem in Florida. And getting to be more of a problem throughout much of the southeast.
Okay, how about next one?
This one was kind of
Focus.
we had more people go for the Botrytis
Sorry.
So
A
I
long
want to say
name.
botrytis, but is botrytis a version? No.
No, it's a different family actually. So these family usually causes more problems. Like I think you guys had a good guess because you see a lot of the trunk problems in this family and causing dieback and this kind of symptoms where the yellowing of the leaves and more like a reflection symptom. But I think what and also John wants to discuss on that. It's what you see on the soil. So whenever we're doing disease diagnosis, again, you have to look the whole picture, the whole plant, and even everything that is buried, like the roots. And in this case, that's what you notice, right, John? Do you want to add anything
Yeah,
about
I
these
guess the
pictures,
big thing
please?
why it wouldn't be that
Yes.
Botrytis is because that's also similar to what I discussed with the cypress. That it tends to impact plants more in sections, and you'll see it much more like on individual branches. This tends to be more uniform, and actually, um, this picture that's on the furthest, on the left hand side, like we got a plant. This is a plant, a picture that's from the clinic, and basically somebody brought some, I yeah, I think viburnums in, and the tips of them were kind of dying. It looked like it was under water stress, but we knew that like they're, if anything, being overwatered right now. And so and this is a fungus. So as you can see here, this is Armillaria root rot, and this is what it looks like in the early stages. So like when it's like this, you just start seeing the plant having problems towards the edges of its leaves and things like that, like of its branches. Some of the leaves just start uniformly dying throughout the whole plant. But this is, you can't rely on being able to necessarily carve back uh, like the areas that are on the stem, because like this is really advanced decay that you're seeing, or advanced stages of the plant of the fungus making its way up to the plant. So this is sometimes I just wanted to point this out because sometimes if they have the plant material there, you got to go all the way down to the roots and like peel off the outer layer of the roots to try and see if that mycelium is getting in there.
Next, do you wanna comment
Yeah.
on that one? There.
Yeah, I'll go ahead. Wait, this one's 15. Yeah.
15.
Let's see. Most people put bacterial gall. That's a little surprising.
Because it does look like something like a gall that either a bacteria or a nematode could cause. But I think in this case, we would talk more about the experience and
Yeah,
seeing
so
symptoms like that.
this is, it's damage caused by the erythroid mites. And I guess the gall, these grow on woody parts of the plant, and if you were to see them, they don't really look like foliage. They look really scabby. They look tumorous kind of. With here, what's going on? I mean, nematodes, that tends to be more of a root problem, and then like also it stresses out the entirety of the plant. It's not concentrated in one area a lot of the time. Witch's broom, you guys saw, that's probably the one I expected people to get confused with this one the most, because it is very specific parts of the plant around the buds. Somebody's asking, what is plant 15? It's a sweet viburnum. So that helps. And yeah, the witch's broom that we were talking about only occurs on hollies. So that's another giveaway. If you can tell that this is a sweet viburnum, which it's got opposite leaves, that helps a lot. But the big thing to pay attention to is like the buds. It's just these pom-pom like malformed buds. And basically the mites get in there. I'm not even sure if they understand completely the mechanism on how the mites do this, but I mean, the mites are so small. If we were to see this, we would have to have like a scanning electron microscope to see the mites, which I guess we'll show you here in a second. But the big thing here is that like it's just a big pom pom the around the buds, and it's the buds are a pretty sensitive area of the plant, and you can see here this is also a roof mite damage on a poplar tree. But this is what they look like. If we get this in, which it's a fairly common thing we see in the clinic, I kind of have to just tell them like, yeah, it's probably mites. There's not a ton you can do about it necessarily. I mean, you can treat it with miticide and stuff like that, but I mean, it's a tough one to diagnose because like most of the insect problems we can see, but this isn't, or insect and invertebrates, like in this case we don't have that luxury. So you just got to pay attention to where the issue is, and if it's around those buds and it looks pom-pommy, there's a good chance it's this.
Okay. How about number 16?
So
that was a tricky one too, right?
Yeah, we got a split here between lightning strike and trunk rot. And
caused by T. leviopsis.
Yeah, we got 19% for boron deficiency.
Okay. Do you want to comment on that?
Yeah, I mean, I guess the big thing here, if it were a lightning strike, you would actually see a lot of the plant being dead. Here you can kind of see like maybe there's like one dead leaf up here, but overall it doesn't seem to be declining. It just looks really malformed.
And yeah, the malformation, that's a pretty typical characteristic of boron deficiency, not only in palms but other plants as well, especially like whenever in other plants you see more on the new leaves forming, and then you see that kind of malformation of the leaves here.
So yeah, and erythroid mites, maybe, like, I mean, that's something that like we just talked about. It tends to, that you tend to have malformations with it, but not like this. This is like twisted kind of, and you're having entire leaves come out. And then the last one, the Developsis trunk rot. This, I mean, if a palm gets this, you would see oozing on the trunk typically, and then like eventually like the trunk eventually just kind of falls over, starts bending. So that's not the case here.
Number 17. Yeah, another.
So I got a question here from someone. Boron is a micronutrient. Is it common to find boron problem in the field? Not really, but more than you would think. Like in Florida, it can happen. There are some areas where we have severe boron deficiencies.
Number 17, John, do you want to comment on this other one that we did, the witch's broom disease?
Yeah, so another example of witch's broom, and yeah, we actually got 44% for the erythroid mites B, but then we got 25%. Witch's broom came in number 2.
Okay.
I guess let's see here. Nematode damage. Nematode damage, like I mentioned, tends to look more uniform, like water stress a lot of the time. It's not just concentrated in ends of the branches. Erythroid mites, they look more like a pom-pom, like we've kind of shown you now, and with very, very tiny leaves. As you can see here, the leaves are fully formed. There's nothing around the buds like that seems like that is like an abnormal growth or tumorous growth or anything like that. And then let's see. Yeah. Bacterial gall. Yeah, the bacterial gall looks like a cancer almost. It looks like a big growth, but it's coming from the woody areas. Here, this is just, when this occurs, you just have a lot of stems or, well, branches come out of the same area. So then that's where where it gets its name. Yeah, that looks like a crazy witch's broom. So,
and moving to 18.
So Cole, yeah, 18. We're 18. Good.
So what did you?
We got most people pick caladium virus.
Yeah, the virus would be different than here. You'd see like kind of little like small spots. And I want to point out for the colatotricum is a fungus. You see those not only the halos but these concentric areas here of symptoms. You see, so and
What's concentric?
circles.
Okay.
Yeah, so in here on the right side it would be a more advanced, and then that's when all these spots kind of merge together and cause the leaf to die and lose parts. But you would be looking at something in here where you have more the symptoms are more limited, whereas in virus you wouldn't see symptoms like that. It wouldn't be that dark either. And again, and you pay close attention to it. I know at the picture sometimes it's hard, but you would be able to see the signs of the fungus here. And for Colatotricum, they are usually orangey. So yeah, that was a good indication that is the fungus and not the virus as well.
So the virus though, they tend to have a lot more like discoloration with them a lot of the time, right? It's not so much like where you see necrosis.
No.
Okay.
Yeah, and the virus that's kind of it tries to like fight for survival, and then you might see some malformation of the leaves as well. But yeah, you wouldn't see kind of this necrotic symptoms. So whenever you see something that is more necrotic, think about bacteria or fungus. Next one, 19, 15 root rot.
We got for 19 most people, well, we got the majority 44% for fusarium. And then yeah, we got a split basically between pythium and nematode damage after that.
Yeah, I know this one is tricky. It is a really, it could have been fusarium wilt as again, and then in this case, a pythium is a womycete, like it's very similar to fungus. But what would call us attention again? We would have in this case to bring it to the clinic and then to a diagnostic clinic and make isolations of cuts on the roots and things like that, so we could actually recover the the pathogen. It's really hard to spot in the field. Again, like you can see, look at that and see like a fusarium wilt because it does look like that. So in this case, it is just a good diagnostic tool, and then sometimes we might not even be able just to looking at it. We need to kind of culture whatever is growing there.
But the roots though too, right? Like the fine root hairs, there's a lot is there something to that with the pythium?
Not necessarily, because fusarium could cause something like that as well. You would see, maybe you still see a discoloration and also reduced number of of like the roots. And the thing with the pythium that it likes water a lot too. So a good indication would be whenever you're like talking to the person that brings the samples, like kind of like asking about the water, or if it was an event like couple weeks, or not even a couple weeks, but a few days after a rain event. So that's when the symptom is more uh, typical, especially because the pythium, they sometimes they have some structures, and then they can swim with the water.
Okay.
So number 20.
Most people got this one.
Yeah.
Magnesium deficiency. I guess there was the next one was sunburn.
Mhm. Yeah, it does look, because it seems like it's kind of facing the sun in this area, so we would have a sunburn. But with nutrients, what it's interesting to point out is like it's very symmetrical. You see, whatever you see in one side of the leaf you see on the other side. Okay, not all the leaves have it, but it tends to be more symmetrical. And then the magnesium deficiency, it's usually this chlorotic, like this discoloration in between the nerves, like the of the leaves. So this is very characteristic. You have the yellowing in between. So I think that's it. And
Well, cool. That's a wrap.
yes, thank you all for joining us today and then participating. And if you have any suggestions or comments,
You know where to find me. So, yeah, thank you very much for being here. And yeah, I hope you guys found this to be the more interactive form of lunch and learn to be kind of fun here. So I guess with that, I'll just go and kick it off for the all members meeting. There's not too much to really cover, but so, oh, thank you. So yeah, I guess I'll just go ahead and just say the big thing that I wanted to cover was Plant Clinic. We're still looking for people for January, and if anybody, is interested, go ahead and contact me and Shalise. We've got a couple of spots that are just flat out open, but also keep in mind that if you want to come back and you're comfortable being across from somebody right now, social distancing, we've got both desks open. So if you're wanting to get back, it's pretty safe here. We try and do a good job cleaning up after shifts and that type of thing. I mean, just let us know and we'll try and work you in starting in January. We're set for the end of the year, but we're adjusting the schedule for January onward. So, and then the other thing I guess is for all people interested, that are involved with the garden festival, just keep that on your calendar. December 1st, we'll be meeting up. We talking about alternatives that we can do, that type of thing. Like, what do the logistics mean moving forward for the year that we won't have a festival? Just Lee will have all your answers. I don't know if you want to say anything right now, Lee, but just I figured it could probably wait until that point as well. We'll go over things in much more detail at that point. But if anybody else, you there, Lee?
I will not have all the answers.
We might have more questions than answers.
We might have more questions than answers, yes.
But we'll be moving towards something. So
yes, we will.
So, but if you want to be part of that discussion, just in your committee chair, or if you're just curious, go ahead and let us know. And it'll be on Zoom like everything else these days. And outside of that, if anybody else has any items or something they want to bring forward, now is your time. Anybody? I'll give you a little bit of time here. Well, all right. Well, it was an honor having you all here today. I hope you liked it. And I hope you're all staying safe and staying well. I've been seeing more people since we've opened up the shifts in the afternoon, and it's good to see people coming back. And that, as we go through the new normal. But anyway, everybody take care. And in 2 weeks, we'll have Tia be giving a talk on seed saving. So, thank you. Thank you, everybody, again. And take care. And we'll see you in a couple weeks.
Thank you, everybody. Thank you.